part. Second, we prepared a lot of nanostructured materials for lithium-ion battery. For the lithium-ion battery, we try to make some materials we call the nano and micro composite materials. Because in the lithium-ion battery system, we need a very high electrode transfer. And we also need the stability of the nanoparticle. If you make a very smaller nanoparticle, the electron transfer speed will be very high. But the stability of a very smaller nanoparticle is not so good. That means this nanoparticle, because the surface area is very big, is not stable. But if you combine this one and the microstructure together, if you can prepare the nano and microstructure and make these two structures together, you can get a new structure. The structure will be very good for the electrode material application. For example, we prepared nanoparticles in the hollow carbon sphere. You see, first like tin. Tin is also a very good electrode material for lithium-ion battery. The theoretical capacity, almost 1,000, is very higher compared to other materials. But the weakness is volume change during charge and discharge. So that means the smaller tin nanoparticle is not stable during the charge and the discharge process. So we think if we can make a smaller nanoparticle and then put all of the nanoparticle together in a carbon sphere, in this case, all of the tin nanoparticle is covered by a confined space. So this smaller nanoparticle should be stable, and the structure will be stable. This work was done by one of my former students. This student graduated from USTC. Okay, now he is a professor in Zhejiang University. Okay, here is the result. You can see we got this result. Here you can see carbon microsphere covered with some tin nanoparticle. So in this case, the tin is 76 weight percentage, and the carbon is 24. And the theoretical capacity is higher than 800. You see, it's very higher than the presently used electrode materials. Okay. We also measure the electrochemical property of this material. Here is the cyclic voltammogram. You can find the different peak. That means different electrochemical process happen in this potential and this potential. And also this peak is very sharp. That means the electrochemical process at this electrode potential is very fast. We also made other composite materials. For example, silicon is also very famous electrode materials. Now, some silicon nanowire is used for lithium-ion battery. Besides silicon, the germanium also a very good electrode materials, you see. But these materials, the weakness is, you see, here is the advantage of germanium, high theoretical capacity, 1,600 is very high. But the weakness is very poor cycle stability because the structure is not so unstable. So how to get a high capacity, high electrochemical conductivity, and also with high lithium diffusion coefficient, and with a very high cycle stability. We try to make a composite material. We call the double protection strategy. So first, we cover the germanium nanoparticle by carbon. After getting this carbon composite material, and then put this composite in graphene layers. So after the double protection, the new composite materials will have a very good cycling performance. Here is the main story. First, covered our germanium nanoparticle with carbon, and then put this carbon in graphene. Okay. Here is the result. First, you see here is the X-ray and the Raman, and here is the morphology characterization. You can find a very smaller nanoparticle. And this nanoparticle, for example, here, the center is the germanium, and here is the carbon. And the end of this composite, here is the graphene. Here is a little bit larger area. You can find the graphene. Here is the nanoparticle. Here is the electrochemical characterization. We use these electrode materials and package lithium-ion battery. You can see here is a cycle number. After here is the 50 cycle. Here is 70 cycles. We also measure several hundred cycle. You can see the stability is very good. Okay, if you use this composite material, the capacity is very high, near 1,000. Okay, and also the cycle lifetime is also very good. Here is the electrochemical impedance spectroscopy. That means after this treatment, the conductivity of this nano micro composite material become much better than pure germanium materials. And here is the conclusion. And we also prepared other nano microstructure electrode materials. You can see a lot of this one. And we measured the electrochemical property. We found some of them are very good, very useful for lithium-ion